The question we are solving now belongs to test series 4. It is of control system subject. In specific, it belongs to Nyquist plot of the control systems. The question is numbered 34. As per the question, the open loop transfer function of a unity negative feedback control system is given as k into 1 plus s whole square divided by s cube. We have to find the Nyquist plot of the control system and we have to find the correct one out of the options A, B, C, D given. For finding the Nyquist plot of the control system, substitute S is equal to j omega. Therefore, g of j omega multiplied by h of j omega is equal to k into 1 plus j omega whole square divided by j omega whole cube. From above, we can see that magnitude of g of j omega h of j omega is equal to k into 1 plus omega square divided by omega cube, and phase of g of j omega h of j omega is equal to minus 3 pi by 2 plus 2 tan inverse omega. Omega equal to 0 plus implies magnitude of g of j omega h of j omega tends to infinity. Means that at omega equal to 0 plus magnitude of the Nyquist plot tends to infinity, and phase of g of j omega h of j omega is equal to minus 3 pi by 2. Similarly, at omega equal to infinity plus magnitude of g of j omega h of j omega tends to 0, and phase of g of j omega h of j omega is equal to minus pi by 2. Also, we see that the Nyquist plot of the control system intersects with real axis for omega equal to 1 radians per second. This is by expanding g of j omega h of j omega in real and imaginary form, we get k into 1 minus omega square plus 2j omega divided by j omega cube. By equating the imaginary part to 0, we get that the Nyquist plot intersects with the real axis at omega equal to 1 radians per second. Also, the system is type 3 system. It means that there will be an encirclement of minus 3 pi in anti-clockwise direction around origin. That implies there is an encirclement of 3 pi around origin in clockwise direction. From this information, we can plot the Nyquist plot of the control system as shown. At omega equal to 0 plus magnitude is infinity and phase is minus 3 pi by 2. So it starts from here, and at omega equal to infinity plus magnitude is 0 and phase is minus pi by 2, and it approaches origin from this direction. Also, the Nyquist plot intersects with the real axis at for omega equal to 1 radians per second. So the Nyquist plot for omega equal to 0 plus to infinity can be drawn as shown. And due to the symmetry, the Nyquist plot for omega equal to infinity minus to 0 minus will be as shown. And also we have seen that there will be an encirclement of 3 pi around origin in clockwise direction. So the Nyquist plot can be extended as shown. From this, we see that correct Nyquist plot of the control system is as in B. So the correct option is